Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and today I'm recording from my house again, and my lovely and derpy wife is making faces behind the camera, trying to throw me off my game again. But you, dear viewer, I'm giving you everything I got, okay? I'm not going to be phased this time. Today we're going to be talking about compound interest. Okay, this is where it really hits the road. This is where real life situations are going to happen. So we're going to be talking about how interest actually grows on itself, and it's called a compound interest. I've got the equation over here you can take a look at if you want. This is probably what's going to show up in every textbook that you have. And we're going to talk about where that comes from, and we're going to talk about it in such a way that you don't have to memorize the formula because you know and understand where it comes from. So let's talk about what compound interest is first, and then hopefully this will make a little bit more sense to you. So let's imagine here for a minute that I am putting money in a bank or in an investment or something, and that bank is paying me interest. Okay, so that's the cool thing when you invest in stocks or banks, the bank pays you so that they get to keep your money. It's kind of a cool deal. So let's just say I put $100 in a bank, okay? And that bank is going to be paying me 100% interest.
Well, that's not real life, but
No,
that would be great.
It would be great, right? How could we write that equation? Remember we talked last time. Remember the equation is always y equals a times b to the x, starting value and the multiplier. Mm-hmm. And when the multiplier has a percentage attached to it, it's 1 plus the rate. Okay? Now, when we're looking at this, I've got the 1, because I've got 100 as my starting value that I put in the bank. Mm-hmm. And then I need to add the rate. So 100% as a rate is just 1.
Oh.
Okay? Cool. So, and then let's say we calculate that for 1 year. So I have 100 times 1 plus 1, which is 2. So 100 times 2, I get?
200.
200, nice. That's a good deal.
Heck yeah.
Now let's imagine there's another bank that's competing for your money. And they said, tell you what, I know that bank over there is paying you 100% every year. But check this out. We're going to pay you 50%, but we're going to do it twice a year.
Oh, getting tricky now.
I am. The question is, which bank's going to give you more money?
Probably the 50% twice a year.
Let's
because
find out.
it's compounded.
Okay. So let's see what happens. I still got my 100. But this time, my rate is only 50%. Mm-hmm. So plus 0.5. Okay, we can actually do this in our head. So 1.5 times 100 is 150. Mm-hmm. Okay, but here's the deal. That now goes back into the bank 6 months later, and I'm going to do it again. So now I have 150 times 1.5. This is a little harder to do in your head, but it's not too bad.
300.
Perfect. 225. Okay?
Oh, it's not 150 times 2. Mm-hmm.
There you go.
Pregnancy brain.
We'll blame it on that. Okay? So this other bank actually gives you more money.
Yep, told you.
So what we would say is this is the phenomenon of compounding interest. Mm-hmm. I can have regular interest, which just compounds once a year, or I can compound more often than that. I say that this has been compounded twice a year. The number of times you compound is how often your interest is calculated. Okay? Do you have any guesses on what would happen if we did it more often than that?
We're just going to keep making more money.
Okay, and you're right. So if I were to compound it quarterly is a fancy word.
4.
Yeah, a lot of people don't know what this means in math, but quarterly just means 4 times a year. So let's see what happens there. And
how much are they giving you 4 times a year?
Well, we'll say the same interest rate, 100%. They gave it to me, split it up, 50% twice. So if I do it this year, it'll be 25% 4 times. Does that make sense?
Yes.
So 1 plus 0.25. Again, that same interest rate, the 25% is going to be 0.25. 50% is 0.5. You can put the 50 if you want it there, but you don't have to because this is 0. So we're going to do that the first time. 100 times 1.25, that's pretty easy. That's 125. Not looking good so far, bank number 3. But we're going to do it again.
Wait.
We're going to do it again. 1 plus 1.25. We're going to do it again. So 100, this one actually in my calculator
Handy
for.
dandy calculator.
Yeah. Times 1.25. We're going to do it again. And we get 156.25. Still not even caught up to the other one, but we'll try 3 times.
You got 2 more tries.
I do get 2 more tries. And you can notice after the first 50%, it's already more than this one at 50%.
Oh, look at that.
Okay, we're going to do that one. So 4 times a year, same interest rate. 100% interest rate. So I started with 100% once a year. 100% that was compounded twice a year. And 100% that was split up 4 times a year. And you keep getting more money. Okay, notice here in my calculator it says 13.75. Fun fact, banks will always round down. They're not going to give you that extra 7 thousandths of a dollar, 7/10 of a penny. They're going to take it. So if you ever have an investment, you always get it rounded down. Fun fact. If you ever have debt,
rounded up.
if you've ever seen at the gas station the 9/10 at the end of the penny, they do that so that they can round up, make a little bit more. All right, so this is the idea of compound interest. I'm taking an interest rate and I'm cutting it up over multiple times a year. So you can write it pretty easily if you want to think about this. So instead of having my B value, again it's all A times B, instead of B being just 1 plus the rate, it's 1 plus the rate divided by the number of times we compound. We usually use N to represent that. Now the interesting thing here is when I did this once, I just did it to the first power. But you can actually think about this as I've multiplied it twice by the same thing. So this was to the second power. It was compounded twice, but the exponent should have been 2. This one I multiplied the same thing 4 times. So my exponent should be 4. But that's also what I compounded my interest by. I cut it into 4 pieces over the year, and I multiplied it by 4. So what's going to happen is your n, whatever your compounding is also going to show up in your exponent, because it's going to increase the number of times you compound. Instead of doing it once, I'm going to do it 4 times. And usually what we do here is we say n is the number of times you compound times however many years you go. And yes, I use a cursive T so it doesn't look like a plus sign.
Cute.
Okay? So keep in mind n is the number of times you compound and that's the same number here, whatever that is. And T is usually years. Okay, the rate is the same thing. It's a percentage. The 1 stays the same. And guess what? Your A stays the same.
Starting value.
Starting value. Though, in most equations, they use the letter P to represent that. P stands for principal, and principal is the amount in an investment that you begin with.
It's not principal, like
Principal.
Stacy. It's principal, P-L-E.
Yes. Okay, spelled like that. Yes, I know how to spell. I know this is surprising to you, dear. All right, so now we have our equation, and whatever you do at the end is the amount. So it's exactly the same thing we started with, 1 plus the rate. The only difference is we're cutting that rate up into pieces. Maybe twice, maybe 4 times. You could do it more times than that. Do you know how often a regular bank will compound your interest?
No, I don't.
Good guess. Okay. A bank will do it 365 times a year.
It's daily?
It's every day.
I was gonna say monthly, but
Yeah,
I thought that was too
They do
often.
it every day. They do it every day.
Wow.
And the reason is so that way you can't take your money out and then put it in right before it's compounded and take the money out.
Oh, smarties.
Yeah.
That's why the interest is so small.
Correct. Okay. Some of you guys might be wondering, does this keep increasing forever? Can I always make more? There is a limit to how much more you can get. Okay, and I'll share a link of a great video on why that is here. So you can take a look in the description. Great discussion. It's about this number called E, which is sort of like pi. It's one of the most important numbers in all mathematics.
E equals mc squared?
Not that one. Not that one. This E is about 2.7, which, by the way, the most you could get in this situation would be $271. But again, you can take a look at that video if you're interested. Let's do an example. Let's imagine that you decide you're going to take some money from high school. You graduated, Nana gives you a bunch of money, and you're going to go ahead and put it in the bank. Or you're going to invest it in something. Okay? Because banks give you garbage interest. Don't invest in a bank. Okay? So let's say you put it in Calbeckistan Industries stock, and they pay 15% per year.
Wow.
Okay? And Nana gives you $200.
Thanks, Nana.
Thanks. Yeah. Let's see what happens. Again, we're going to plug this in to our equation. Y equals A times B to the X. Don't forget, that's exactly the same thing. Okay? And here's the deal. Calbeckistan Industries gives you monthly compounded interest. Okay? So let's see what this looks like over some time. The first thing is we're going to plug in our starting value, which is 200. My interest rate, remember, is going to be 1 plus the rate, which is 0.15. And it's compounded monthly. So if we remember our equation, that's how many times I calculate the interest. It means I'm cutting it into pieces. I'm going to cut 15% into 12 pieces. And then, however many years I've got, if I put it in for 5 years, then it's the number of months in 5 years. So it's 12 times whatever number of years I've got. And this is something you can type into your calculator. I would recommend, when in doubt, use lots of parentheses. So I'm going to say 200 times 1 plus 0.15 divided by 12. Make sure that's all in parentheses before you take it to a power. And then make sure this is all in your exponent. 12 times, how many years do you want to find out?
5.
5 years? We've been doing that a lot lately. So after 5 years, you have doubled your money in Calbeckistan Industries.
Yeah, Nana.
Okay? And we can do this again. So maybe we can check a different number. Let's just say you want to know how much money you're going to have when you retire.
Oh.
Okay? If you guys retire at 65, that's 47 years.
Whew. Price of a new car.
That is $200,000.
Wait. No. This is... Oh.
What are you looking at?
I don't know. Goodness, I only saw 22,000.
Yeah.
Yeah, that's a house.
Yes, it is. Well, probably
not here.
Not in 44 years, but...
Not here in this state.
You're going to get $220,000. Now, this is the power of compound interest. Starting with 200, I just keep calculating that interest 15% every single month for 47 years. That's a big number, right? It's not T. That's 47. And because I can't do that in my head, that's 564 times it's been compounded, and you end up with $200,000 from Nana. Okay, and this is the power, and this is why people invest. That's why Wall Street has all those big buildings. Okay, it's because people are investing money for the long haul. They're making a lot of it because it's compounding their interest. Okay, and again, don't put it in a bank because you're going to get less than 1%, even in the best of cases right now. 15% is a very, very good interest rate, probably higher than you'd expect to get in most stocks, but not impossible. Okay, let's take a look at another case. Let's say you buy a house. All right, when we bought our house, let's see, think we bought it for $395,000.
Should you say that?
Yeah, who cares?
Okay.
Everybody hides things about money, and then nobody ever gets to learn about what really happened. Pretty standard, or pretty typically over the time we've owned it, it has increased by about 8% per year. Okay? But let's be honest, the housing market is changing all the time. So we're going to say that this changes daily. Okay? It compounds daily.
Mm-hmm.
And we bought our house 6 years ago, so we're going to see how much it's worth.
What is this squiggly line?
That's a 6! All right, and we're going to plug this in. Okay, same equation as we had before. $395,000 is our starting value, or our principal in this case, the amount that we invested. Again, we didn't buy this in cash, by the way, so we're paying the bank back. That's what you call a mortgage. But this is 0.08. And daily, I'm going to cut that interest rate up into 365 pieces. But since it's cut into 365 pieces, that means it's being compounded every single day. So we're going to have 365 times t. And we can go ahead and plug this in. I'd recommend, again, as you're doing these, use the parentheses on your calculator if you're ever worried about making sure you have stuff. So we got 365. Again, putting that all in parentheses before you take it to an exponent. And then we've got 365 times 6 years.
Whew.
That is a lot of money. Okay? Now, in reality, it's not this much because this has gone up and down a little bit. But you can see that 8% has almost doubled the value of our house, and it's only taken 6 years.
It's a lot of money.
It is a lot of money. It's kind of crazy, right? If only we owned some of that. That's how much the bank makes if they sell it. Okay, so, but the thing is, this is how much it's worth to me, but I only had to pay the bank this much, which is kind of a good deal. Okay, so that's how compound interest works. I hope that's helpful in your calculations. Again, try to invest early. The earlier you can invest, the less money it takes. Your $200 from Nana can be $100,000 when you retire, pretty easily. Okay, your house, buy a house. That's a great investment, and if nothing else, even if it's a mediocre investment, at least it's going to grow a little bit. Okay, so compound interest hopefully is really useful. Go ahead and ask any questions you have in the comments. Be happy to do that. Kristi, thank you for constantly trolling me throughout all of my videos. Give a thumbs up if you liked having Kristi here. And I'll see you guys next time. As a quick personal note, some of you might find it weird that I was talking about the actual value of my actual house in a video about math. I do that on purpose because I think so many kids go through high school and parents kind of assume that school is going to teach them all about math, all about the ins and outs of money and how to be smart with it. And the truth is, because of all the restrictions that are put on us by the state and everything else and what we have to teach, we often don't have a ton of time to do that. I work really hard to make time to talk about it, particularly in the exponential unit. But I want to use real life examples so kids understand what real money looks like and what, how to win with money. So parents, I would really encourage you guys to be real with your kids. If you've made mistakes with credit cards or with debt, tell them about that so that they can avoid those mistakes in the future. If you're a kid, ask your parents. Be like, Mom, Dad, what does it mean? What is a mortgage? What does it mean to pay off interest? What does it mean to invest in the stock market? Ask those kinds of questions now, so when you get to the point where you have your own job, that you understand what to do. You know how to avoid the mistakes and pitfalls that just can doom a decade of a person's life trying to dig out of debt or making bad choices. So parents, be real with your kids. Kids, ask about stuff with your parents, and I'm going to try to lead by example here and sharing kind of my real life story. If you do have any questions, I'd be happy to share those things. But I think the more we can be real with our younger generation, the more likely they are to not make the same mistakes that we might have. So that's why I'm real with you guys about actual numbers and real house. Even though that might seem weird to you, I do it on purpose, and hopefully you can follow that example. So that's it.